Ever feel like trying to actually use the amazing breakthroughs you read about in machine learning research is like, well, like being handed ingredients for a gourmet meal,
Right.
but no cooking instructions.
Oh, absolutely.
You see these incredible ideas, but that crucial step, the code that brings them to life, it's often missing. It's frustrating, right?
It really is.
Like having a map to buried treasure, but no shovel.
Yeah, that's a good way to put it. It's a common hurdle. These papers, they excel at laying out the what and the why of new discoveries,
Right.
making a compelling argument for their findings. But they aren't really designed to be software manuals. And the paper we've been looking at highlights this perfectly. It said only about, 21% of papers from top machine learning conferences this year actually shared their code.
21%. That's it.
That's it.
Wow. Okay, so welcome to this deep dive, everyone. We're tackling that very problem today. We're diving into PaperCoder, a fascinating technology that aims to be your, AI translator for those dense research papers, automatically turning them into actual runnable code.
Exactly.
Think of it as the ultimate cheat sheet that not only tells you the answers, but shows you exactly how to get there.
And our goal today, specifically for you listening, is to understand the magic behind PaperCoder without getting bogged down in, super technical jargon.
Yeah, keep it simple.
We'll be drawing from the research paper, Paper2Code, Automating Code Generation from Scientific Papers in Machine Learning. That's the paper that introduces and rigorously tests this technology.
Okay. And our mission for this deep dive, to demystify how PaperCoder works its wonders.
Right.
And to explore how this kind of tech could shake things up for all of us. How might it change the way we learn, innovate, and maybe, just maybe, finally understand some of those brain-bending research breakthroughs. Okay, let's unpack this then. Why is this missing code such a big deal in the first place? Seems like a detail, but clearly it's not.
Yeah, you're right. It's not minor at all. As we kind of touched on, the main purpose of a research paper isn't really to give you a ready-made software package.
Okay.
It's about sharing new ideas, backing them up with evidence, persuading other scientists that they're onto something important.
Right, the argument.
Exactly. Providing all the nitty-gritty code details, well, it's vital for reproducing the work, obviously. But sometimes it's seen as secondary compared to those core goals.
Right. So the paper says only about 1 in 5 papers from major ML conferences in 2024 included code. That's wow.
Yeah.
Imagine trying to build with Legos, and the manual only shows you a picture of the finished model and a list of pieces. No steps.
Exactly. You'd be left scratching your head, probably building something totally different. And this leads to just a huge waste of time and effort for researchers.
I bet.
When the original code isn't there, they basically have to become detectives, trying to piece together the methods, the experiments, just from reading the paper. It can take ages, often leads to mistakes, which, slows down progress for everyone.
Yeah, if everyone's busy reinventing the wheel, who's designing the better car, right?
Precisely.
Okay, so our mystery needs a solution. Enter our high-tech hero, PaperCoder. Tell us in simple terms, what exactly is this thing?
Okay, so at its core, the paper describes PaperCoder as a multi-agent LLM framework. LLM meaning large language model.
Okay, sounds fancy. Break that down.
Right, it sounds like a mouthful, but picture this.
Yeah.
It's like having a team of super smart AI assistants, all powered by the same kind of tech that makes those sophisticated chatbots so clever. But instead of one giant AI trying to do everything, you got a well-organized team. Each member has specific roles.
Okay, so it's not just one brain trying to juggle everything. It's more like a specialized SWAT team for research papers.
Exactly. That's a great analogy. And their main mission, according to the paper, is to take these incredibly dense scientific papers and automatically create a complete working code repository from them.
A working one.
A working one. Think of it like getting a ready-to-run software package that perfectly implements the research described.
That sounds, almost too good to be true. So instead of spending weeks wrestling with a paper and then trying to code it from scratch, you could potentially just feed it to PaperCoder and poof, there's the code.
That's the big idea, yeah. Imagine having a research assistant who's not only brilliant at understanding complex academic writing, but also has the coding chops to actually build the experiments being discussed. It's all about bridging that gap between the theory in the paper and the practical reality of working code.
Okay, this is where it gets really interesting for me. How does PaperCoder actually pull this off? What's the secret sauce here? The code conjuring trick.
Well, the paper outlines a pretty clever three-stage process that PaperCoder follows.
Yeah.
Planning, analysis, and then generation.
Okay.
To make it super clear, let's maybe go back to your house building idea.
Okay, I'm ready to build. Lay it on me.
All right. So the planning stage is like drawing up the blueprints for our house.
Got it. Blueprints.
PaperCoder first creates a high-level plan. What are the main parts that need to be built? Then it designs the system architecture. Think of that as a basic map showing how all the different rooms.
Or code modules.
Exactly. Code modules, how they'll connect and interact. You wouldn't build a house without knowing where the kitchen connects to the living room, right?
Right.
PaperCoder maps out how the code pieces work together. It also figures out file dependencies. What needs to be built before something else.
Ah, okay. Like walls before the roof.
Precisely.
Yeah.
You can't put the roof on before you have walls. And finally, it generates initial configuration files. That's like gathering all your lumber and tools before you even swing a hammer.
Okay, so it's getting its ducks in a row. Before it writes a single line of code, it's got this detailed strategy. Making its grocery list, sharpening its pencils, before cooking.
You got it. Next up is the analysis stage. This is where our AI architect looks closely at those blueprints and figures out all the precise measurements and specs for every single part of the house.
Yeah.
Or, for PaperCoder, every file and function of the code.
So real detail work.
Yes, really focusing on understanding the intended purpose. What information goes in, what should come out. How does this piece fit with everything else? This stage is all about making sure every little cog in the code machine knows exactly what its job is, based directly on what the research paper describes.
Okay, so it's not just the general idea. It's like sweating the small stuff, understanding the tiny details of what each bit of code needs to do.
Exactly.
Like knowing not just that you need a door, but how wide, how tall, what kind of hinges.
Perfect analogy. Then we move to the final stage. Generation.
Oh, it's the construction phase.
This is where the actual building begins. Based on that detailed plan and analysis, PaperCoder starts writing the code.
Okay.
And importantly, it writes it in a specific order, following those dependencies it figured out earlier.
Right, the walls before the roof thing.
Exactly. Builds the foundation, then the walls, then the roof, making sure everything fits together snugly.
Finally, the construction crew arrives. PaperCoder starts cranking out the code line by line, making sure every piece fits. It sounds very organized, very thoughtful, not just random code spitting.
It is indeed. It's a structured approach.
Yeah.
And the researchers went to great lengths to actually see how well this organized method works.
Which, yeah, brings us to the million-dollar question. Does this thing actually work, like in the real world? What results did they see when they tested PaperCoder?
Right. So to find out, the researchers created something called the Paper2Code benchmark, and they also used another existing one called PaperBench.
Okay.
Think of these like standardized tests, sort of like giving different AI code generators the same research paper and seeing who builds the best working code from it.
Like a coding Olympics for AI.
Oh, in a way, yeah. And the results for PaperCoder, they were really impressive.
Oh.
The paper consistently showed that PaperCoder outperformed other existing methods, what they called strong baselines, by, and this is the term they used, substantial margins.
Substantial margins. I like the sound of that. Not just a little bit better.
No, significantly better.
Okay, give us some highlights then.
Well, in their evaluations, a remarkable 77% of the code projects generated by PaperCoder were rated as the best by human experts.
77%. Rated best by humans. Wow.
And maybe even more impressively, 85% of human judges. And this includes the original authors of the research papers themselves.
The actual scientists who wrote the papers.
Yes. They found the code generated by PaperCoder to be genuinely useful.
Whoa. Okay, if the original authors think the AI's code is helpful, that's a pretty solid thumbs up.
It's a very strong endorsement, yeah. And perhaps the most surprising finding,
Go on.
was that the generated code often needed very little tweaking to actually run correctly. On average, they found only about 0.48% of the total lines of code needed manual changes.
Less than 0.5%. 0.48%.
That's right.
That's like getting a super complicated IKEA manual for a spaceship, and you only need to correct like one tiny typo for it to be perfect.
Exactly.
Okay.
It suggests PaperCoder isn't just producing code that looks kind of right. It's producing code that is actually functionally sound right out of the box, mostly.
Incredible. Okay, so this all sounds very exciting for folks deep in machine learning research, obviously. But let's bring it home for our listener. Someone who might not know a tensor from a toaster.
Right.
Why should this PaperCoder thing matter to you? What's the potential impact on your work or maybe just your daily learning?
That's a really important question. Because even if you never plan on writing a single line of code yourself,
Yeah.
PaperCoder represents, I think, a huge leap forward in making complex knowledge accessible to potentially everyone.
Okay, I'm listening. How so?
Well, think about it this way. If tech, like PaperCoder, can dramatically cut down the time and effort it takes to understand and implement cutting-edge research, what new possibilities open up then? We could see much faster progress in all sorts of scientific fields. Researchers could build on each other's work much more easily, much more quickly.
I see. It's like suddenly everyone has a universal adapter for their research, making collaboration smoother.
Exactly. Less time spent struggling with the technical weeds means more brain power focused on the next big discoveries.
That makes perfect sense.
Absolutely. But it goes even further, I think. Imagine the potential for AI to become an even more powerful learning tool for all of us.
How do you mean?
If an AI can take a dense scientific paper and generate practical examples or interactive simulations or even simplified tools based on that research, it could democratize knowledge in a really profound way. You could potentially gain a much deeper understanding of really complex topics without needing years of specialized training first.
Right, those aha moments we all love. This kind of tech could lead to a lot more of them, maybe.
That's the hope. It could
Well-
make things click.
So it's not just about making life easier for AI researchers. It's about potentially making complicated information more understandable, more usable for a much wider audience, including you listening right now.
Precisely.
That really fits with what we know our listeners want, gaining knowledge quickly, thoroughly, without feeling totally overwhelmed by the jargon.
Exactly. Technologies like PaperCoder could lower the walls around complex ideas, fostering innovation, fostering learning in all sorts of fields, even ones you might not immediately connect with computer code.
This is definitely something to chew on. So as we wrap up our exploration here, what's the main takeaway from our deep dive into PaperCoder? What's the nugget of gold we should all remember?
I think the core message is that PaperCoder is a really valuable new technology. It's actively working to bridge that often huge gap between exciting research ideas and their practical application.
Okay.
By automating that process, turning papers into working code, it's making complex science more tangible, more accessible, hopefully to a wider world.
And that brings us to our final thought for you, the listener. What new doors might open when those barriers to understanding and using complex research are significantly lowered? How might technologies like PaperCoder change the way we all learn, the way we innovate in the years to come? It's a fascinating question to consider.
It really is. And if you are curious to dig even deeper, you can find more details in the original research paper itself.
Right.
And the code is actually available on GitHub. We'll make sure to include a link in the show notes for this deep dive if you want to check it out.
Perfect.
It's been a truly insightful journey exploring this.
Absolutely. Thanks for taking this deep dive with us today. We're already excited about our next exploration.